Hello everyone, welcome back to the another session in design and analysis of algorithms. Today the topic name is search engines. This topic you'll find in 4th unit as topic number 9. Now let's get started. So basically what is search engine? We were unknowingly using search engine for many reasons in our daily life. The name itself it tells that search engine is a complex computer software programs designed to search an information on the World Wide Web. So when I'm talking about this World Wide Web, it is something like internet. Now the world is in internet. Everything is available in the internet. If everything is available in the internet, let's say that everything will include all the education policies or information about the colleges and information about the government and information about the many things. That the world is in internet, that means everything is in internet. If I wanted to search something, I have to give an access with all the contents what are available in the internet. Now you need some process where it gives you allowance to search the content inside of these websites, correct? Now so search engine is what? Search engines are complex computer software programs designed to search an information on the internet and produce users the best results in fastest possible way. So basically we all know Google is the search engine, but it is not only the search engine what we have other more search engines, example Yahoo, Bing. So 70% to 80% people will use Google, and that's what it is more familiar. It is more familiar than the rest too. Yahoo and Bing is used by 30 to 20% of the population to search some document or some keyword in the internet. Now, so with this we understood something. Let us see that it is what a search engine. Now this search engine what it will do is it accept one key from the user. Now let's say that I wanted to search database. Now what search engine duty is, whatever keyword I'm giving as part of user action, that keyword search engine program will take. That's what I specified here, it is a program. Now the input of the program is what? My keyword. This keyword will be taken by this program, and what this program will do is this program will match this keyword with all the content of internet. When it will go to check all this content, it should given with the access first of all, correct? Now that's what we need to look for. Three different keywords which are crawling, indexing, ranking. Now crawling is basically it is what the database which is available with the search engine. So it will be going to have a bulk of data, something like you can say it is a dictionary. Now you will be having a bulk of data with this crawling, and indexing is what each will be given with a indexing, and whereas based upon the keywords we will be matching with this dictionary and we will be giving all the information in the web page, correct? So now here all cannot be come in single line. If you see something like at the same example I'm using database. Now database key will be available with many websites, correct? So now what crawling will do is crawling will maintain the database of these websites. Now whatever the website is having database keyword, that all the web pages will get available on the screen. Now what is indexing? Based upon the accessibility it will be giving the indexing for each keyword. Now ranking is also a what I have to say, ranking is the algorithm where search engine will be following to optimize the results, right? Now, so let's understand one by one search engine. The World Wide Web contains a huge collection of text documents which are web pages. Information about these pages is gathered by a program called web crawler, which then stores this information in a special dictionary database. A web search engine allows users to retrieve relevant information from this database, thereby identifying relevant pages on the web containing given keywords. Now, whatever information it is there, it has to organize that information. As I told in the previous example, if you wanted to search a keyword which is a file, now the keyword is what? I wanted to search a file keyword. Now when I give this file keyword is associated with many of the websites. Now all this website information is available in the form of database with the search engine. Now this file from the search engine optimization, it has to be organized and it has to be sort and it has to be stored. So these are what the functionalities of search engine optimization. Now let me talk about the inverted file. What do you mean by inverted file? The core information stored by a search engine is a dictionary called an inverted index. Now what do you mean by this inverted index? The core information stored by a search engine is a dictionary, and that dictionary is named as inverted index or inverted file. Now the way how this information is available in this index is what? With the pair. The pair is what? W comma L, where W is a word and L is a collection of references to the pages containing word W. The keys or the words in this dictionary are called index terms and should be a set of vocabulary entries and proper nouns as large as possible. The elements in this dictionary are called occurrence list and should cover as many web pages as possible. Now, an inverted index can be efficiently implemented with a data structure consisting the following properties, that is, an array storing the occurrence list of the terms if in no particular order, a compressed trie for the set of index terms where each external node stores the index of the occurrence list of the associated term. Now, the reason for storing the occurrence list outside the trie is to keep the size of trie data structure sufficiently small to fit in internal memory. Instead, because of their large total size, the occurrence list have to be stored on disk. A query for a single keyword is similar to a word matching query. The keyword is searched in the trie and the associated occurrence list is returned. Now, it is in the case of a single keyword. If I give, now let's see, let's talk that I have a single keyword. Now this single keyword will be taken as a query, and this is what similar to you a word matching query. The keyword is searched in the trie whatever we have and that associated occurrence list is written. If it is in the case of multiple keywords, when multiple keywords are given and the desired output is the pages containing all the given keywords, the occurrence list of each keyword using the trie is retrieved and their intersection is returned. To facilitate the intersection computation, each occurrence list should be implemented with a sequence of sorted by address or with a dictionary. In addition to the basic task of returning a list of pages containing given keywords, search engines provide an important additional service by ranking the page. Written by relevance. Devising fast and accurate ranking algorithms for search engines is a major challenge for computer researchers and electronic committee companies. So this is how the way we will be working with search engine. Naturally, when you are storing some information in the dictionary, that you will work with either main memory or else disk access, correct? So always it is quite natural in the memory perspective that there exists a great time difference in between main memory access and disk access. Now, the main goal of maintaining a dictionary is in external memory, it is to minimize the number of disk transfers needed to perform a query. Now we have to reduce this performance. What the performance? Accessing of information. So since sequence dictionary implementations are inefficient, the logarithmic time internal memory strategies using balanced binary trees, which are AVL trees, R&B trees, red and black trees, or other search structures with logarithmic average case query and updated times can be considered. Now, this method stores the dictionary items at the nodes of a binary tree or of a graph and require transfers in the worst case to perform a query or updated operation. Now, to reduce the performance difference between internal memory access and external memory access for searching, dictionaries can be represented using a multi-way search tree, where this tree is not needed any rotations as you need in AVL tree. This tree is not needed any balancing factor as you needed in R&B tree. So this tree is what it is, AB tree. Now we are going to talk about this AB tree. The purpose of using AB tree is what? To satisfy the goal of external searching or to satisfy the goal of search engine. What is the goal of search engine? The main goal of search engine is to maintain a dictionary in external memory is to minimize the number of disk transfers needed to perform a query or any update or any message or something what is given by the user as part of the input to search it. Now we'll be going to use this data structure, and that data structure is what? AB.